Hello and welcome to Long COVID Foundation podcast. My name is Dr. Valentina Viduta and I'm Long COVID Foundation trustee. This channel is for long COVID sufferers, researchers, practitioners, and a whole host of other people who wants to learn more on COVID. Please take the second, like our videos, subscribe to our YouTube channel, and stay up to date. The Long COVID Foundation aims to find the best rehabilitation solutions for long COVID sufferers. We provide the knowledge that you can use to get necessary treatment from your general practitioners. So stay tuned, like our videos, and subscribe. Hello and welcome back to our podcast. Today we have invited Professor Antje Baranova to share her knowledge on post-COVID recovery and share her ideas on how people in America do recover and what are the best practices. So hello Antje and welcome back to our podcast.
Hello, Valentina. Very glad to see everybody.
Thank you for supporting this channel and sharing your knowledge to our viewers. We really appreciate you do it for us. So thank you so much. And today we wanted to discuss post-COVID recovery. So people do feel really tired after having this acute COVID, then this COVID symptoms, which last for 6 months and more. So people really are struggling with the recovery itself. Can you give us any advice? What are the first and main things people can do without seeing doctors, or maybe see doctor for something that is really helpful at the first instance?
Well, that's very difficult to give everybody universal advice, of course, but at least something we can say. And this something is coming from the knowledge of human physiology and human metabolism rather than from clinical studies or clinical trials on one or another type of treatment. I am sure that within the next couple of years, we will have it on the 10 years horizon as well, that post-COVID research would be one of the main areas of the research. And I'm sure that in the next couple of years, we will have trials of actual treatments which would be aimed at enhancing the recovery in post-COVID patients, but we are not there yet. And one of the reasons why we are not there yet is because it takes time. We simply cannot jump to the future. Scientists, in order to create some kind of clinical trials, they need to start with basics, and then they need to establish connections with physicians in order to enroll patients. And right now, physicians are very busy with acute COVID, and post-COVID, of course, falling out of the scope. We need to deal with immediate problems first. But I'm sure we will be there. Like same way as we had war on cancer for dozen years, I would say already, like 2 years we have war on cancer. I'm sure that we will be having similar thing on post-COVID. So from where we start right now, without the necessity of clinical research or clinical trials, we need to start with something safe. That's the foremost. If somebody is telling you that there is some exotic toxin from some frog in the South America and this diluted toxin cures everybody from post-COVID, I would be very cautious about it. But on the other hand, there are other medications which are common medications. They're over-the-counter. Majority of those medications or over-the-counter compounds, so to speak, like herbal compounds, they are available without prescription. And that means that they are safe. The other medications, of course, are considered safe generally, but you might have some kind of specific condition which might be interfering with this medication. So this field, of course, is brought to caution as well. But still, it's much safer than the frog from South America. Yeah. So let's put everything into perspective. So how we can derive the knowledge how to treat ourselves on post-COVID? Well, we can get it from some other studies of other diseases or conditions which are having more or less similar pathophysiology. The good example here would be the chronic fatigue syndrome. Chronic fatigue syndrome is a very vague condition. It is happening with people after viral diseases. And I want everybody to understand that post-COVID and chronic fatigue syndrome are two different entities. But maybe in some aspects they have some commonalities. One common thing is fatigue. So if we would treat fatigue as isolated symptom, if we would not be diving into various kinds of additional things which might happen with the coronavirus patients, like post-viral myocarditis, with various kinds of dysautonomy, we spoke about them earlier, but we will be talking only about fatigue. We can learn a lot from the treatments of chronic fatigue syndrome. There were many things tried. And the only thing which really worked in more than one studies was the support with L-carnitine, which is a small molecular metabolic compound, which is available without prescription. Usually people can get it in like sports nutrition stores or on Amazon, something like this. And this compound simply the same L-carnitine which is in our body, so it's not foreign to our body, it's part of our body. And what L-carnitine is doing is serving as a shuttle for lipids to go into the mitochondria. So after coronavirus infection, many people have the problem with lipid metabolism. So they have bad cholesterol going up, low levels of good cholesterol, etc. You know, all this happening with people commonly. They get prescribed statins in situation when the lipid formula goes totally out of the window. But statins, their common side effect, have a fatigue. So if people are fatigued to begin with, then the treatment with statins may actually enhance the situation instead of subsiding it. When you are applying carnitine, then the lipids are going into the mitochondria at higher rates. In mitochondria, they will be burned, those lipids, into the smaller compounds. In the process, ATP will be generated, so you will have more energy in form of ATP and also NADPH. That's one thing. And another thing, you would be burning those fats. And those bad fats would go away from your bloodstream. So it is like a double good thing in the same drug. What is happening in the situation of post-COVID is that we have mitochondrial exhaustion. Our mitochondria cannot burn things as efficiently as they did before. Carnitine is a little helper. Another thing is that the carnitine could be used as a complex with other compounds. You can use not only carnitine, but other little helpers which will help other organelles within your body. But chief organ which will need help, this is mitochondria. And there is more than carnitine which you can do for mitochondria. Because mitochondria, how they made, they actually like cells within cells. Within the cell we have mitochondria, and those mitochondria have membrane. In this membrane we have a lot of proteins which are forming electron transport chain. So in order to burn something, you need this something to go in. That is with the help of carnitine, stuff is going in. But also the overall mitochondria, in order to work properly, it should be alive. Those shouldn't have any holes. It should really feel well. So the mitochondria, in order to make them less leaky, you need to take care about their membranes. And membranes suffer a lot during coronavirus infection. Not only mitochondrial membranes, but also cellular membranes and also various kinds of envelopes around special kinds of cells like nervous cells, like neuron, myelin envelopes will be suffering as well. So they will all suffer. But mitochondria will suffer most. Why it is so? Because their membranes are most densely packed with proteins. So they are packing so many proteins in that there is not much space for actual lipids. So if something happens with those lipids, if those lipids will get damaged, that's much faster influences fluidity of the membrane in the mitochondria in comparison to other membranes. So mitochondria would suffer first. So you need to do something for the membrane, and you would be doing it for membrane of mitochondria, but of course other membranes will benefit as well. So no other cell would, or some component of the cell would actually suffer. Everybody will benefit, but mitochondria will get largest benefit. What is this little helper for mitochondria? That is actually lipids. Yes, the cholesterol, for example. The cholesterol itself is not so bad molecule. It just we gave it bad name. We started to mix up cholesterol and triglycerides and the fatty acids all together. That's actually fatty acids which are good for you or bad for you. But cholesterol as such, really, it's not even metabolizable straight to energy, just a structural component. It's like a brick, you know, you're not eating bricks, you're making some fireplace with them. So if you are having problems with metabolism and with membranes, you really need to make sure that only good lipids are going in, plus you have enough of this cholesterol compound, which is used as a brick for making your steroid hormones and also for making your membranes fluid.
Now, if I am a patient in a post-COVID clinic, what and how should I approach doctor and tell that this is happening to me? So what are the tests that doctor can do to see I do have this?
Fortunately, here I couldn't help you much because here is the problem. Theoretically, we do diagnose mitochondrial diseases, but we do diagnose them in children. And those are genetic diseases. So the people who are most aware of various kinds of problems with mitochondria, those are human geneticists who are working with children who do have special disorders of the metabolism. Those people, those doctors, they never see adults. They may see adult if adult is growing from a child who used to come as a patient to this practice, but not really new adult patients. If you are growing to adulthood without big problems and you never were diagnosed with mitochondrial disease, it is assumed that your mitochondria is working perfectly and whatever happened with your energy is just part of natural aging. So yeah, COVID is aging you like 20 years and the doctors can say, well, you know, you don't have energy anymore, get adjusted to the situation, you're not that young anymore, you know, stuff like this. We do have tests to check for mitochondrial energy, but usually those tests are not really easy to do. Regular doctor will never prescribe them, and also they are laborious. They really need to have a very good reason to administer this test. For example, many tests would require a biopsy, like a muscle biopsy. Yes, not a good thing. On the other hand, many tests could be done not on muscles, but on the peripheral blood cells. But still, they will take venous blood and they will take live cells out of the blood, and then they would work with those cells in the plate. It cannot be cheap, but even without this test, if you're having low energy, it is relatively safe to try to augment your mitochondria in order to correct for this defect. And we are correcting with carnitine, we correcting with correction for the membranes, and there are a couple of things which you can do for membranes. One, you can use choline, for example. This is a vitamin which is playing a role in the metabolism of the fats. You can use amino acid called serine, because serine is the molecule which gets conjugated with certain fat and make phosphatidylserine, which is part, especially internal part of the mitochondria. That's a very important one. And you can buy it as a supplement, as phosphatidylserine, and there are works which are showing that this type of supplement is very good for Alzheimer patients, for example. I'm not saying that everybody who is on post-COVID having also beginning of the dementia. No, not like this. But if it's good for people who are that far away already at this cognition line, should be good for you too. So you should use this comparative logic and bring it from the other areas of the study. So the carnitine, the serine, amino acid, choline, which is used to be a vitamin. Choline is the vitamin discovered as vitamin was called vitamin B4. You remember those B vitamins 1, 2, 3, and then gap. Yeah, so there used to be vitamin B4 there, the choline. And then some group of scientists triumphantly showed that yes, choline could be made in the human body. There are biosynthetic enzymes for that. That led to the demise of the choline. It was removed from the list of the vitamins, non-essential, you don't need it. But the problem with this kind of line of study was that, yeah, it can be made in the human body if needed. If like you have dire circumstances, you can make it. But first of all, one of the byproducts of this process of making choline is toxic for human body. That's homocysteine. So you really don't want to do this vitamin hard way. It's more healthy to get it from outside. And second, your body kind of understands that the toxic compound is produced in exchange for making choline, and it's really pushing you to get choline from whatever source you can get, and you have craving for fatty foods. But when we are using fatty foods, majority of fatty foods which you are getting are really not good fatty foods. So you want fatty foods, you start eating French fry. Not good, yes. Fish and chips, not really good thing. Much better way to get choline and to get lecithin, which also having this phosphatidylserine in it, is to get like chicken eggs. Even better if instead of chicken eggs, you'll get quail eggs.
Mm-hmm.
And even better if you actually eat raw quail eggs. It's quite safe. You can eat raw quail eggs. Of course, you need to wash them, and then you need to be very careful when you break them. You don't need to put entire egg in your mouth, you understand, right? You need to take out the content of the egg, and eggs would be fresh, and they actually sold in the shops, and you can eat a couple of them every day, and that would in a week or so raise back your natural choline levels to the level which is normal, and you would not need to produce new choline using the toxic compound called homocysteine. So that's another thing. And so there are many of those little helpers. But now we have two more important questions which are remaining. First important question is how much? How you can find out how much you need of each compound.
Mm-hmm.
And typically we take whatever is in the bottle, right? So you have bottle and it says 500 milligram or 300 milligram, whatever is in the bottle. And we usually look at the bottle, it says once a day or twice a day or something like this. Very few people realize that all those data are very approximate. Nobody ever ran any kind of trial saying 500 grams versus 1 gram versus 250, how much is much, and whether every person has the same requirement. Maybe healthy people don't need it or need a little, and sick people with certain condition need a lot of it, yeah? Like if you have deficiency, for example. Fortunately, right now, we are having means to sort out those kind of things. Those means called mass spectrometry. There are devices called mass spectrometers, which are available in many scientific labs. And with those mass spectrometers, you can do very quick on-the-fly studies of the metabolism by drawing the fluids like blood or urine in patient immediately after ingestion of the compound. So if you do like setup study, metabolic study, when you have patient who is your subject for the study, it's not for treatment, it's for the study of the metabolism, and you give this patient that amount of supplement, that larger, yes, or you have couple of patients like this, and then you measure amounts of this component or its metabolites in the blood, patient just on the blood drip, 15 minutes after he had the compound, 30 minutes, 45, 1 hour, 2 hours, etc. So patients basically spend 24 hours in a day, and you know how much is enough to produce enough metabolic change in the organism to see some physiological effect. And those studies actually were made with many compounds. The very typical example is caffeine. For caffeine, which is both food compound and also medicinal compound, we know exactly how much is much for which kind of metabolism, which kind of underlying genotype, who can drink coffee in the morning and be okay, who can have 10 cups of coffee and be okay, yes, and who cannot take caffeine at all. And we really can do that in the simple laboratory test. And right now, those laboratories are being done. And what's interesting that as for classical vitamins, we know more or less those so-called RDA, recommended daily amounts.
Mm-hmm.
That for other compounds, which are not classical vitamins, there was never a requirement to get those recommended daily amounts. And we are only right now trying to discern them. Just because it's just regular food compound, like serine, amino acid. You are getting it with the food anyway. Yeah? You're getting a lot of it with the food. So if you add compound on top of it, it needs to be summed up with your daily amount which you eat with the food. More difficult task, but it's been done. And surprise, surprise, those amounts which are actually influence something in your body are quite large. They are still safe, at those large ranges, but they are not in the range of one couplet. Like, for example, we discussed the carnitine, which is metabolic component. Typical study for the chronic fatigue syndrome used between 4 to 6 grams of this compound per day.
Wow.
4 to 6 grams of this compound per day. I repeat it. Of course, they are not in a bolus, so it's not like you are drinking 6 grams of carnitine. Not good. But you are stretching it through the day because you really need like a little support. Like every 2 hours, you drink part of your daily dose, and that is going very evenly through the day, and that helps you. And with time, you replenish your mitochondria. In 2 weeks, you're feeling better. In 4 weeks, better. So typical study for chronic fatigue syndrome use this treatment for 8 to 12 weeks. So 8 to 12 weeks, up to 6 grams. And of course, people do not start with 6 grams. They start with 1 gram, 2 gram, 3 gram. Yeah, because you might get some intolerance, like food intolerance or something like this. So in such case, you would have to stop. But majority of people were able to take it without any problems, and they really felt better. But it's even more interesting for some other compounds. Like, for example, this compound which is called serine. It's just amino acid, same as which is found in the food. And you know what's about this? It's up to 24 grams a day. This is actually the treatment which has been used recently. The paper published in the medRxiv. It's not published officially as the paper yet. It will go through peer review, but I read this paper and I can tell you, as one of the people who are doing peer review regularly, this paper is quite fine. So it will be published. You know, we just would go through some minor editing or something like this. That's a quite good study which has been done with patients not on post-COVID, but during their acute COVID period. So as soon as they got the diagnosis, the study was done by scientists in 2 countries at the same time. One was Turkey, another Sweden. And the reason why they did it in Turkey, because Turkey is really, scientifically speaking, not a third world country. They do have scientific labs and everything, very good scientific labs. So the mass spec study they did in Turkey, actually. And the reason why they started the study, because they did this metabolic study before COVID. They were studying those limits of how much exactly you need to apply metabolic compound in order to get to metabolic correction, not just to add something, like not like a little cherry on a cake, yes, but really fix something. So they were finding and publishing previous papers that you really need large amounts. So in this particular study, what they did, they took patients who just got COVID, acute COVID, and all those patients were getting standard treatment for COVID, for like early stage. They get disease with fever, etc., but they were not hospitalized. They started at home. And they randomized them in 2 groups. Those 2 blind groups. One group was with supplements, another without supplements. And the supplements they gave to them was as follows. They had 4 compounds together, 4 compounds. One of them was carnitine, L-carnitine, in the form of carnitine tartrate, and they get that 7 grams a day. I will send you the reference and I will copy that to you so everybody will see it in writing. Yeah. So that was 7 grams a day. They had 5 grams a day of N-acetyl-cysteine. 5 grams a day. It's like 9 couplets of N-acetyl-cysteine a day, standard dose, yes? They had 2 grams of nicotinamide riboside chloride, and this is another mitochondrial compound, and had also 24 grams of serine. So they divided it in 2 portions, morning portion and evening portion, yes? Those were the same portions. And of course, it was very important to note that they are using it after meal. Because if you take it just on the empty stomach, your stomach would, tell you never do it again, yes? So I can imagine it's not a pleasant mix to drink on the empty stomach. But they were using it after meal. So after you eat, like 20 minutes after meal, you are getting this mix. And that comes in the mix with the food and just get together with the food. The group of people who were using this mix in comparison to the group of people who didn't use the mix, they recovered from COVID faster. They felt lesser amount of symptoms. Their fever went down faster, and they developed post-COVID in lesser percentage of cases. That was for the early COVID. But because COVID exhausts people and post-COVID is really something which is attached to COVID, it makes sense to try it at the post-COVID stage.
Absolutely.
Just in their study, they were preventing the problem.
Mm-hmm.
In this situation, we are trying to recover from the problem. And one should not be afraid of those large amounts because they actually are tested in people, and people felt better, not worse from that. Said that there are always a possibility of some individual complete intolerance, because also remember those are pure compounds, right? So they were cleaned up in the process. You might get intolerance to some component which is in the minuscule amounts was added in the process of clean up. It is a possibility. We have little intolerances. If you have one of them, don't try to overcome it. Yes, there are 4 compounds.
Mm-hmm.
Of course, you are intolerant most likely to one. So try to remove them one by one, find out what you are intolerant to, and the 3 is better than 0. So yeah, if you cannot use all 4, then use 3 of them. Would be not so bad. And I hope that we can hear some results. Again, this is all compounds are over the counter. They all being sold. They all used in the sports nutrition. They all used in the regular nutrition. So there should not be anything bad with it. And also, you have time. Those people who get the treatment with acute COVID, they didn't have time. They were just enrolled in the study and prescribed to take something. But in your case, you have time. So you can start with smaller dose and then increase the dose if you see that it's well tolerated.
Do you know how they identified that these 4 components is something that they need to give to patients?
Of course, they just identified by thinking about it. They didn't do any kind of screenings or anything. It's just our body is organized according to certain metabolic map. And because we read other papers on COVID and we know what happens with patients, we can identify where there are weak spots, which would be most likely affected by coronavirus. Because other viruses, they hit in the same place too. So yeah, viruses commonly affect mitochondria, commonly affect membranes, etc., etc., etc. Just COVID is doing its greater evil. It's able to do it at the larger scale. But we knew about it. We knew about it in other conditions. And it makes sense to bring the knowledge from other conditions to our understanding of coronavirus and how to treat it. And this is the way how you can try to help yourself with fatigue.
Thank you very much for this overview and the information you provided to our channel. See you next time if you're gonna have time.
Absolutely. Thank you so much.
Let me remind you that all our videos are for educational and informational purposes only. For medical advice, please speak to your general practitioner. Thank you for watching and see you next time. Bye!